Hey boys and girls, today I'm going to introduce you to some vocabulary and ideas about force and motion. We're going to start by watching a Scholastic Study Jam together that has some of your basic vocabulary, and I'll stop and talk to you about things like I do at school throughout the video. Let's go.
Okay, Sam, let's practice that kick of yours. Show me what you got.
Here goes nothing.
Okay. If you're gonna reach the goal, you're gonna need a lot more force than that.
It's not force I need, Mia. It's skills. I'm just not so great at soccer.
Sam, skills aren't gonna do you any good if the ball doesn't move. And if you want motion, you need force. Watch.
Now that's what I call a kick.
Thanks. What it really is force. A force is any push or pull on an object.
So right there, you need to know what a force is. It's any push, any pull on an object. There. Pretty easy, right?
And your kick was quite the push.
Definitely. Before, the ball was just sitting there, waiting to be moved. The force of my kick sent the ball into motion. The crazy thing is, if my kick was the only force pushing on the ball, then it would just keep on moving. It would never stop.
That's impossible.
Okay, so here's the idea. All right, so let's watch a tiny little bit more.
No, it's not. It's inertia.
Okay, so what she was just saying is the hardest, or one of the hardest things to think about with force and motion. If there were no forces in action when you started something into motion, so just like she said, the soccer ball with your foot kicking on the soccer ball, if there were no other forces, that ball would keep on going forever and ever and ever and ever and ever. Now, up on the screen, it has the word inertia. Inertia is Newton's first law. So there's this guy named Sir Isaac Newton, and it'll probably happen inside of this video that we talk about it some more. But Isaac Newton came up with 3 science laws. Now, we already know the law of conservation of mass, right? That you can't create matter or destroy matter, so the mass stays the same. That's one of the laws that we already know about. Newton had 3 laws plus a law of gravity. The first one is the law of inertia. And it says right here, inertia, which, by the way, it looks like inertia. That's not how you say it. You say inertia. Inertia is the tendency of an object to resist change to its state of motion. In other words, if the ball is going and you apply force, it will go forever if there are no forces acting against it, which is why you might think about in space. In space, there's not air, and remember that air is matter, so when something is moving through space, it keeps on moving until it hits something else and goes a different way. On Earth, we have our atmosphere, which is full of air, so everything that has motion always has to be, will always get stopped because our air is going to act on it, rubbing against it, which is called friction, and slowing things down. So the idea is with inertia that things want to keep doing what they're already doing. Newton's law says an object in motion stays in motion, an object at rest remains at rest until a force is applied. That's literally the law, and we'll talk about that a little bit more later.
The tendency of an object to resist change in its motion. Inertia is what kept the ball still before I kicked it, and keeps it moving once a force is applied. Once something starts moving, inertia will just keep it going.
But what if that was like a bowling ball you just kicked? Bet inertia couldn't move it so far.
Well, a bowling ball would have barely even moved with the tiny amount of energy you kicked with. It's got a lot more mass than a soccer ball, and objects with more mass respond more slowly to force because their mass actually increases their inertia.
So that...
All right, now think about that. If inertia is the tendency to keep doing what you're already doing, the ball in this picture right here, that bowling ball, because it has more mass, it's more likely to stay right where it is. Because remember, inertia is the idea that objects like to continue doing what they're already doing. When that ball is just sitting there, it takes a lot of force to make it go because it has a lot of mass. Whereas if you had a tiny little ping pong ball and you kicked it, it would take less mass to get it to move along.
That means it's harder to move things with a lot of mass and harder to stop them, right?
Exactly. But once you get those masses moving, inertia takes right over and keeps things rolling.
Now let's also keep in mind what he just said, and that is that things, when they are moving or when you're trying to apply force to them, if they have more mass, it's harder to move them. Keep in mind that it is also harder to stop things that are moving if they have more mass. Think about this. If you have a giant semi truck racing at you and you try to stop it, are you going to be able to do it very well? No, right? So something with more mass takes more force to start or to stop.
Just like the soccer ball. Well, unless...
Unless I stink as bad at kicking bowling balls as I do soccer balls?
No, unless another force is applied to it, like gravity pulling it down, or friction. Friction is a force that acts against moving objects.
Is that what made my ball stop?
Well, that's part of it, yeah.
Now listen, they just mentioned two forces. And for fifth grade science, the two forces you have to know are gravity, which is the force that pulls objects back to the earth. We always think of it as falling down. Gravity pulls things down. But really, gravity is pulling things into the earth. Because remember, the earth is a giant sphere, right? So gravity pulls things in from space to the earth. So wherever you are out in space, you would be pulled to the earth once you get into our gravitational pull. But looks to us like things are falling down, which they are. However, from space, it would be falling in every direction because the earth literally pulls in with its gravitational force.
Friction acts between surfaces that touch. The friction that stopped the ball was caused by the bumpy, rough texture of the grass. The force of friction fought against the force of the kick.
And it looks like friction won against your kick, too.
Looks like you're right. That ball's done rolling for now.
Definitely. So then how do we beat the force of friction and get the ball to keep moving?
Well, the more friction there is...
Oh, the more force you need to apply?
Exactly. Or more newtons.
Fig Newtons.
No, Sam. A newton is a measure of force.
Ah.
Anyway, you were right. Greater force equals a greater change in movement. And the more force you want, the more energy you'll need.
Of course.
Aha. Now you say of course, but when you kicked that ball earlier, I didn't see you put much energy into it.
Well, I had no idea I was fighting a battle against friction. Now I know just what it takes.
Not so fast. Sometimes, friction's not the only thing you're fighting against. Gravity is another force that can work against motion.
Whew. Friction, mass, gravity. No wonder this soccer business is so hard. That's like a whole team against one rolling ball.
Well, you just gotta come to the field in full force, Sam. Ready to give it one more shot?
Well, if you're talking about the basics of force, I think I've got that down. A force is a push, like a kick, or a pull that acts on an object. We need force to set objects into motion, and the greater an object's mass, the more force that's required to move it. Force not only moves things, it stops them too. Friction is a force that acts against motion and can stop an object in its tracks.
But not this time. Go for the goal, Sam.
Oops, guess I'm quite the force to be reckoned with now.
And as always, they end with a dumb joke. All right, we'll do another video in a second. Rewatch this one as needed. Make sure that you watch and watch and watch until you really understand.